In this video, we're going to do an example of finding the resultant force and moment. This time we're going to do a three-dimensional example. So in this question here, we have a pole like this. And it has these dimensions right here. And then it has this platform sticking out about 1 meter here. It has a force applied to it. Then at the top of the pole, it has two forces applied to it, F1 and F2. And over here we have the values for the different forces, and they're conveniently already written for us in Cartesian vector form, which comes in very handy for making calculations. And then what we're asked to do is we're asked to find the resultant force and couple moment of this system here. And we know that the resultant force is equal to the sum of forces, and we know that the resultant moment about point O, okay, so we're asked to find the resultant couple moment about point O, to be specific, is equal to the sum of cross products of R cross F. So how do we do this? Well, let's start with the sum of forces. Okay, so we're going to do the sum of forces first. And the resultant force is going to be, we're going to do the individual components first. So we know that the resultant force, so Fr, okay, along in the x direction is equal to the sum of forces in the x direction. So to do this, what we simply do is we just collect the i's, we just sum up all the i's here. Okay, since they're already written in Cartesian vector form for us, it makes our calculation that much easier. So what it's going to be this 300i plus this 100i. Now this term does not have an I, so it'll just be 300i plus 100i. 100i plus 100i. And what we get, okay, and this is all in newtons, and what we get is 400i newtons. Okay, so that means that it is going to be 400 newtons in the positive x direction. Okay. How about the y? Okay, so what is the resultant force in the y direction? So Fr in the y direction, well, we know that it's the sum of forces in the y direction. And so to do this, what we do is we just sum up the j's here. So we have 400j minus 100j, and the F3 does not have a j, so it's just going to be 400j minus 100j, which will give us 300j newtons. Okay, so 300j newtons. So we know that it's going to be in the positive y direction, since the answer is positive here. And then next we're going to get the resultant force in the z direction. Okay, so we know that it's going to be the sum of forces, the sum of forces in the z direction. And like before, we collect the different z terms, or the different k terms. So we have 100k, or negative 100k, minus 50k, minus 500k. So when we do that, we go negative 100k minus 50k minus 500k. This is in newtons. When we sum all these up, we get negative 650k newtons. Okay, so when we write our final answer, our resultant force, Fr, actually I'll create a little more space here. Fr is going to be equal to 400i plus 300j minus 650k newtons. So 400i plus 300j minus 650k newtons, and that would be the answer for the sum of forces. So as you can see here, when it's already in Cartesian vector form, it makes our answer that much easier. So now let's do the sum of moments. So we know that the resultant moment about the origin is going to be equal to the sum of r cross f. So we're going to be taking the cross product of r and f for each force here. Okay. Now, if you are not comfortable with taking cross products, no need to worry. I've made a video and I will link that to this video for you to reference. But moving on with this question, we're going to be taking the cross product of this distance to this force here, plus the cross product of this distance and this force, plus the cross product of this distance and this force here. Now, there's a slightly shorter way of doing it, and I'm going to show you how to do it. But what I'm going to do is I'm going to do the long way first, and I'll show you how to do the shorter way first. Or sorry, the shorter way after. So we have the sum of moments, or the resultant moment about the origin is going to be equal to, and what I'll do is I'll use some slightly different colors here. So is equal to R1 cross F1, so this force here, plus, and then we'll go R2 cross F2, and then plus R3 cross F3. And so what that will look like is this here. So we'll put in our table, so we have the I term, our J, and our K. That's for this vector here. And so F1, what is the distance? Okay, what is R? Okay, so that would be the distance from the origin to this force here. Well, it has no x component, so r would be 0. It has no y component, so it'll also be 0. But it does have a k component. And as you can see here, it's 8 meters, and then plus this 4 meters here. And 8 plus 4 is 12, so we would get 12. And then, how about F1? Well, we know that F1 is equal to 300I plus 400J minus 100K. Okay, here's that first cross product there. How about this one here? How about the next one? Well, F2, what is R? Well, let's start with, let's put in our I's, J's, and K's. Let's not get ahead of ourselves. Okay, so what is R? So that is, what is the distance from the origin to where the force acts? Well, it has no x component, so it's going to be also 0. It also has no y component. And then the x component is going to be the same as, or sorry, the z component is going to be the same as this, as F1 here, so it's going to be 12. And then what about F2? What is F2? Well, we have 100I minus 100J minus 50K. Okay. And then last but not least, we have F3. So we're going to put in our I, J, and K. And what is the distance? Well, we know that it has no x coordinate, so that's going to be 0. It does have a y coordinate though, and it goes 1 meter in the negative y direction, so we're going to put -1. And then it goes up 8 meters on the z-axis, so it's going to be 8k. And then F3 has no I term, it has no j term, it's just negative 500 and there we go. So now what we can do is we can go on and calculate the cross product from here. Which would give us the following. So our final answer would be this right here, negative 3100I plus 4800J, and in Newton meters. Okay, so that would be our final answer there. So now the question becomes, how do we do this in an even shorter way? Well, take a look at this here. So if you look up at F1 and 2, you'll notice that they both act at the same point. So what we can do then is just replace F1 and 2 with a resultant force, okay, by summing up the vectors of F1 and 2, and then instead of doing 3 cross products, we would just do 2. So we do the sum of F1 and 2, or we do R cross the sum of F1 and 2, plus the cross product of this R here and F3. So I'll show you how to do that. So scroll down, okay. And so we would write a new force, we'll call it F12. So that is the resultant force of F1 and F2, okay. We'll say F12 is equal to F1 plus F2, which would give us, and if we just add up these vectors, so 300I, 400J, 100K, and this vector here, we would get this 400I plus 300J minus 150K. So that when we go and do our cross products now, instead of doing 3 separate ones, we'll just do 2. So we'll scroll down and we'll write this. So we'll go the sum of moments about the origin is equal to R, we'll call it 1, 2, cross F1, 2 plus R3 cross F3, like that. So when we put it into, when we put our cross product table in, we would get this. We would get I, J, K, and we'll have 0, 0, 12, and then we'll have 400, okay, that's this here, and then 300, 300, and then negative 150 plus we'll have our I, J, and K, 0, negative 1, 8, and we'll have 0, 0, negative 500. And we'll scroll down and create a little bit more space here. And now we'll just go ahead and compute the cross product. So we would get this. So we'll start with this first one here. So along the, for the I term here, we would cross out this term and this term, and then we go 0 times negative 150 minus 12 times 300. So 0 times negative 150 minus 12 times 300 I. and then we'll go minus, okay, 0 times negative 150, and 12 times 400. Times 400 J plus, okay, we cancel this out, it'll be 0 times 300 minus 0 times 400, and we know that that's just going to be 0. So we got 0 K, or 0 K. Okay, and then the next thing we do is we just add this cross product here, okay, which we've already done up here. And we know from this previous calculation up here that R3 cross F3 is equal to 500i. So instead of redoing the entire calculation, I'm just going to bring it down here. And we got 500i. And this is going to be in Newton meters. So now what we do is we'll simplify. We'll simplify this. And in doing so, we get this vector here, negative. Okay, so this goes to 0, and this is going to be negative 3600i minus negative 4800j, and then it's just going to be 0k, so we can leave that out. And then plus 500i, like so. And then now what we do is we collect the terms here. Okay, so as you can see, that when we sum this up, negative 3600i plus 500i is equal to negative 3100i. And then negative 4800 is just going to be positive 4800. Positive 4800J. This will be in Newton meters. And as you can see, that we get the same answer here. So this would be the resultant couple moment.